because it's not necessarily at x equals 0. But we know the output is 0 here. Then we know everything on this interval has to be either positive or negative, and everything on this interval has to be positive or negative. And this is because of the intermediate value theorem. If there were another, or if over here it was positive on this part and negative on this part, then we know by the intermediate value theorem that there must also be a 0 on that part, because you have to have every value in between positive and negative, which includes 0. Since we know where the 0 is, and it's only right here, that precludes any 0 being anywhere else. And so we know that no, in fact, we can't have both positive and negative on the same interval. We can only have one or the other. And so earlier on, like chapter 1, we were dealing with solving various equations, and we use this fact a lot, and it actually comes from this more robust theorem. Okay, so the last thing I'm going to say is actually the last part of the notes. 3.2 was fairly short. And so the last thing is, again, about the multiplicities. So we can list a couple of properties. So if f has a 0 with even multiplicity, like for example it's x minus 2 or x plus 1 squared, so this is going to be 0 at x equals negative 1, but this is telling us that it's actually 0 twice at the same point. And what this looks like is it's going to be a parabola that just sort of kisses the x-axis right there at negative 1. So for an even multiplicity, this turns into something which approaches the x-axis and then bends sharply without ever crossing it. Whereas for something similar, but with odd, so here I'll actually write it down, with even multiplicity, bends sharply and never crosses the x-axis. But if f has a 0 with odd multiplicity, then it does something different. So this is going to flatten and cross the x-axis. And we can see that also in the notes, but we can see that if we have something like x minus or x plus 1 cubed. So now we have an odd exponent, or an odd multiplicity for the 0. So again, it's going to be 0 at negative 1, but it's not going to approach it and then turn away, and it's not just going to go straight through. It's going to do something like, and get really, really flat, and then cross it. And so right here, there are technically 3 zeros all overlapping or coinciding at the same point. So for even multiplicity, it bends sharply away and only touches the x-axis, and for odd multiplicity, it flattens out and crosses the x-axis. And so these two facts can be used in conjunction with everything else to give a better sketch of the graph. I think, yeah, that's the end of the notes that I prepared, because that's the end of 3.2. So yes, hopefully this gives you everything you need to for the homework due this Friday. Again, with the global pandemic situation, things are going to be a lot more flexible. If you have extra questions, please, I would invite you to, number 1, go to your textbook, which I know you bought because you need it to get online access to WebAssign. If that doesn't help, go to the notes, which I just gave an overview here, but they go into more detail on Blackboard. And if you still have questions, please post them publicly onto CampusWire so that everyone else can benefit from the answer. Yeah, I think that's it.